Welcome to polynomial functions.
Now let's look at example 5. For example 5, we're asked to graph the polynomial p of x equals 2x to the fourth plus 4x cubed minus 6x squared. Now our first step is to use the leading term test to determine the end behavior of our polynomial. So our leading term this time is 2x to the fourth. And so notice with our leading term that we have a positive leading coefficient and an even exponent. So if we look back at our leading term test, notice that that falls under this category here in the top left. A is greater than 0, it's 2, and n is even because it's 4. So our end behavior is going to have arrows pointing up in the first quadrant and the second quadrant. So let's go ahead and draw our arrows in. The next step is to find and plot all x-intercepts. In the last example, it was fully factored for us. In this case, we're going to have to factor p of x and set it equal to 0. So we have 2x to the fourth plus 4x cubed minus 6x squared. And we're going to set that equal to 0. Now to solve this, we factor. So the greatest common factor here, well, we look first at the numbers, notice that they share 2 in common. Also, they share x squared in common. So we're going to factor out 2x squared. When we factor that out, we could do some side work up here. If I factor 2x squared to 2x to the fourth, let's see what we're left with. So I'm going to take 2x to the fourth and divide by 2x squared. Well, the 2's are going to cancel, and then the x squared on the bottom will cancel, and we're going to be left with 2x's on the top. So this is going to equal x squared. So right here, we're going to have x squared, and then we have plus, we're going to take 4x cubed and divide by 2x squared to find out what happens when we factor 2x squared out. So we have 4x cubed and we divide by 2x squared. That's going to equal, if I take 4 and divide by 2, I get 2. And then I've got x cubed over x squared. The x squared in the bottom will cancel and we'll be left with 1x on the top. So this is just going to be 2x. So plus 2x here. And then we need to factor 2x squared from negative 6x squared. So we have negative 6x squared divided by 2x squared. That's going to equal, if I take negative 6 and divide by 2, I get negative 3. And then my x squareds cancel. So we have minus 3 here. And then we're going to set that equal to 0 still. Then we can factor this trinomial here, x squared plus 2x minus 3. We're going to factor that. So I'll just finish doing some side work up here. When we factor this trinomial, it's pretty simple to factor. We're just looking for the two numbers that multiply to make negative 3 and add to make positive 2. And you could just write down your factors of negative 3 and find that. But you're going to get positive 3 and -1. If you multiply those, you get -3. If you add them, you get 2. So then here we have 2x squared and then we have times x minus 1 and times x plus 3 is equal to 0. So I'm going to take 2x squared and I'm going to set it equal to 0. And then I'll divide 2 into both sides. And then I'm going to get x squared equals 0. And then I want to undo the squaring by taking the square root of both sides. So I get x equals 0. So my x-intercept is going to be the point 0, 0. And then we have the factor x minus 1. If I take x minus 1 and set it equal to 0, all that I'm going to do is add 1 to both sides, and I'm going to get x equals 1. So my x-intercept then is the point 1, 0. And as a reminder, remember at the x-intercept, the y value is always 0. And then the next factor that I have is x plus 3. So I'm going to take x plus 3 and set it equal to 0. To solve this, all I'm going to do is subtract 3 from both sides. So I'm going to get x equals -3. And so this x-intercept is going to be -3, 0. And then we can go ahead and plot our x-intercepts. So we have our x-intercept 0, 0. We have 1, 0. And we have -3, 0. And then our next step is to determine the multiplicity of each 0 and use this multiplicity to decide if the graph will cross, bounce, or wiggle at each 0. So for the first one, the factor has an exponent of 2. So the 0 associated with this factor here is x equals 0. Since the exponent is 2, the graph is actually going to bounce at x equals 0. For our next factor, x minus 1, there's an understood exponent of 1 here. That means that the 0 associated with that factor is going to cross straight through the x-axis. So the graph is going to cross straight through 1, 0. Likewise, for the factor x plus 3, there's an exponent of 1. So the 0 associated with that, which is x is equal to -3, the graph is going to be crossing straight through that 0. Our next step would be to find and plot the y-intercept. Well, notice here that one of our x-intercepts was the point 0, 0, which is actually the y-intercept. So we've already found the y-intercept. So we can go to the next step. which is to plot any test points needed and finish drawing the graph. So again, test points are nice because they let us know how far up or how far below the graph is going in each interval. So let's look at this interval from -3 to 0. We want to find a nice central point, which would be -1.5. We're going to do a test point for that. So we're going to find P of -1.5. And that's going to be approximately -16.9. So we have a test point at -1.5, -16.9. And I'm just using my calculator here to find the y value. You can do that as well. So let's go ahead and plot our test point. This is -1.5. Notice that our scale is counting by 5s, but we do have these small grid lines as well. So we have -1.5, and this would be -15 here. And -16.9 is just shy of -17, so it's probably about right here. This is just a good estimate. So our next interval is between 0 and 1, so we need to choose a test point right in the middle of that. So we'll choose 0.5 to find out if the graph is above or below in that interval. So let's find P of 0.5. So P of 0.5 is approximately -0.9. So we have the test point here, 0.5, -0.9. And we can go ahead and graph that. So 0.5 and then -0.9. Let's see, this is -5 right here. And -0.9 is about -1. So it's going to be about right here. Okay, but we see that it's below the x-axis. So our graph is going to come straight down from the second quadrant. And then it's going to go through our test point. And then it's going to bounce off of x equals 0. And then it's going to go down through our test point. And then it's going to cross straight through x equals 1. And then we can erase these other arrows. We don't need them anymore. And so there's our polynomial. Here's a picture of the graph that I did of the polynomial in the graphing calculator. You can compare it to the one that we just drew by hand. It looks very similar. Well, that brings us to the end of this lesson. The next lesson that you'll want to watch the video for is section 3.6, rational functions. I will see you then.